we're going to get underway with notes. First, we're going to look at our homework, though. So, a reminder, you have a quiz next class over what we learned today, as well as factoring. Today's stuff isn't that bad. Alright, so here's the homework answer key. Go ahead and take a look at your answers, see if they match up, see which ones you have questions on. So notice that 1 through 3, it does not have an equals 0, and the instructions say just to factor, so we stop at factoring. Here it says to solve the following. So solving, we have equals, we should finish with x equals. Alright, so we'll go over 6. Here's 7, 8, and 9. Do not forget about quadratic formula. When we're factoring, just factoring, it's not set equal to 0, then you can say prime. But when it's solving, and you put prime, great, the quadratic's prime. I don't care, I want it solved. So use quadratic formula when you cannot factor it. I think there's in the notes. Oh, number 11, make sure you factor out any GCF first in the beginning. Alright, and then 13 and 14. Make sure you do simplify your quadratic formula answers as much as you possibly can. You need to reduce those factors when possible. Also, thank you to those of you that actually did do number 14 and attempted it. I appreciate that. No questions on 13 or 14? No. Okay, let's take a look at number 6 then, since that was the one we had a question on. Remember, quiz next class. Alright, so number 6 on your homework. Was 4x squared. Minus 64 equals 0. Alright, for this one, I am solving. The instructions say to solve, as well as the fact that we have an equal sign, so my answer should be x equals. Okay, so here we just have x squared. You can factor this. It's a difference of squares. So you could factor this into, because it's 2x squared and 8 squared. So you could factor this into 2x minus 8 times 2x plus 8. But an easier way, because we only have x squared, we can actually just use square roots to help us out. So here I just add 64. I get 4x squared equals 64. Divide by 4. I get x squared equals 16. Square both sides. And what must we do when we take the square root when we're solving?
Plus and minus.
Good. Plus or minus. If you would have factored this, you would have gotten the same thing here. 2x minus 8 equal to 0. 2x plus 8 equal to 0.
Couldn't we have taken out like a 4 at the beginning?
Yeah, you could have factored out a 4 in the beginning, and then you would have had x squared minus 16, which would have gotten you quicker to the answer. And you see that we get the exact same result here as well. So you can use factoring difference of squares there to help you out, but when we just have an x squared and there's no x, you can use square roots as well. Okay. Did I hear someone say 3?
Yeah.
3. Can I borrow your paper? Alright, and then we'll take a look at 3, then we'll move on to notes. Alright, number 3. This is a special type of case. Please stop talking while I'm talking. Thank you. This is a special case called difference of squares. And this is where we have a perfect square minus another perfect square. 2x squared is 4x squared, and 5 squared is 25. And notice that we're just factoring here, we're not solving. There's no equal sign, so I should not have x equals at the end. Alright, so difference of squares. I take my first minus the second times the first plus the second. And that's it. You can always FOIL it back out to double check to make sure you did it right. 4x squared plus 10x minus 10x cancel each other out. The beauty of difference of squares. You're saying stuff like hey. Yes,
Wait, but don't you like, it's like, so if you 2x squared, it's not like 2x, then you put parentheses next to it, so next to the, like, 2 times 2, then 2 times x, then x times 2, then x times y.
Are you thinking foiling?
Yeah.
So like if I were to FOIL this back out, 2x times 2x would be 4x squared. Then 2x times 5
I
would be
actually
10x.
remember Eric doing it first.
Minus 10x minus 25. The positive 10x and negative 10x cancel each other out.
Oh yeah, never mind. I was thinking just times it in the first one, so you don't have to.
Yes.
Multiplication.
You're right, yeah, this is just multiplication up here. Okay. Go ahead and pull out your notes. We're going to move on to that. A reminder again, you have a quiz next class. It includes what we are doing today, and it includes factoring and solving. You need to know that quadratic formula. You need to know how to factor. You need to know how to solve. That's why I've been making you do it for like 5 months now. 5 months.
Those are very positive thoughts.
Okay, starting right away with notes. Now today's topics, what we're doing today are standalone topics. Because of this few days time before Christmas break, we're taking some of these individual topics that can be done by themselves outside of a unit. And that's what we're doing today. So you'll see at the top it says that this is from section 5.6 and 8.1 in your book. And a lot of this stuff you will probably think is super easy, and some of it you may already know from middle school. Yeah, maybe even last year. I'm not sure. Some maybe elementary. I don't know.
Preschool.
Okay. So we have some new theorems. Not all of them have names. Our first two do not have names. It says this is the Jack Adams theory. Alright, if one side of a triangle is longer than a second side, then the angle opposite the first side is larger than the angle opposite the second side.
Are we doing
No name.
Let's wait for the demonstration.
I love the example. Okay, so let's take a look at this and interpret it. So here's our triangle. If one side of a triangle is longer than a second side. Alright, so AC here, the measure of AC, that's larger than the measure of BC. Alright? Here's BC. So it says if one side is longer than another side, the angle opposite the first side. So my first side was AC. What angle is opposite of AC?
ABC.
Right, we'll just call it B. Alright, so the angle opposite the first side, so the measure of angle B, is larger than the angle opposite the second side. Alright, angle opposite the second side. My side BC, what angle is opposite of that? Hey. So all this theorem is doing is saying that your sides, the ordering of your sides, corresponds with the ordering of the angles opposite of it. Your longest side, angle opposite of that is your largest angle. Your shortest side, the angle opposite of that is your smallest
That's not the
angle.
shortest side.
I know. But here's two. We're about to do our third one.
Oh.
So the order of the sides goes along with the order of the angles opposite. Okay. So let's satisfy Sarah. We have also side AB. So side AB, that's the shortest here. And what is the angle opposite of side AB? C. So what we're saying here, another way of looking at this, is that going from, I think we went from largest to smallest here. Go side AC, then side BC, then side AB.
Yeah, but couldn't you say that AC was bigger than AB starting out?
Yeah. Which, if you remove that, AC is bigger than AB.
Yeah, but then if you were gonna put BC, how would you know? Like if you did the same thing and then you had BC left over as the last one, and you stuck it on the end, then that would.
Well, you'd have to compare BC to one of your sides. So is AC larger than BC?
Yes.
So then that would have to go after AC. Is BC larger than AB? No. So then it would have to go before AB. Okay, so again, all this is saying is that your longest side, the angle opposite of it, is your largest angle. Smallest side, angle opposite of it is your smallest angle. Medium side, the angle opposite of it is your medium angle.
So are we gonna need this to use some proofs? Like
Not yet.
this angle is the smallest angle?
Not yet. I didn't give you any proofs for homework.
No.
All right, our second theorem. Our second theorem here is just going the opposite direction. Vacation.
She doesn't understand that she has to get
That's
explained
for
to turn around while I'm talking. You don't.
Probably shouldn't happen.
Okay. So my second theorem here is actually just going the opposite direction. If I know the order of my angles, then I know the order of the sides with it. So if I know that angle B is the largest, A is my middle one, and C is my smallest one, then I can go the sides opposite of that. So I'm starting with my bottom piece here. If measure of angle B is greater than measure of angle A, the side opposite of that, AC, is going to be larger than the side opposite of A, BC. It's just going the other direction. Yes, this is just the converse of the first one. The converse of the first one is true, thus that's a theorem by itself. Yes, sir.
Why do we like using, like, what does it help you for the length of angle?
If you look at the next example, that's exactly what we're going to use there. So what this allows us to do is, given a triangle and not given any of the information about the angles, only the sides, I can know whether it's I can know which angles are larger, which angles are the largest, which angles the smallest. So this allows me to tell information about my angles given only the sides, and vice versa. This allows me to tell information about my sides only given the angles. Okay, so let's go and do an actual example because I feel like it's a lot easier when you just have numbers in the thing. So our first example here says list the angles of the following individual triangles in order from largest to smallest. Okay, so my first one here, which side is my largest side? TS. And what angle is opposite of that? So angle R is going to be the largest. My longest side, angle opposite of that is my largest angle. My longest side, the angle opposite of that is your largest angle.
Wait, what if you can't tell?
I give you numbers there.
Oh, never mind. I didn't.
The previous picture, I made it obvious enough for us to know, but they would have to give you information. Okay, what's my next largest side?
RS.
Good, RS. And what is the angle opposite of RS? Good, so that means angle T is going to be my next largest angle. And then what's my smallest side? What's my smallest side? Good, RT. And the angle opposite of that is S. So angle S is going to be my smallest. if you think about it, let me pull up a couple lines here. Okay, so here I have two sides making this angle, and I can see the length here is approximately going to be this right here. Whoa, that's a thick line. Let's try that again. Okay. Now, if I take my side and move this down, notice how it creates a larger angle, and thus this side has to be larger as well. So you can see that as the opening of that angle changes, the side opposite of it also has to change in length to accommodate for that. So the longest side, largest angle is opposite of that. Smallest side, smallest angle is opposite of that. Okay, so go ahead and do the next one if you haven't already. Give you 15 seconds for this. Okay, so for triangle WVU, which angle is the largest? Good, angle V. Here's my longest side, so that's angle opposite of that. V must be my largest angle. Alright, what's next? Angle U. Again, here's my next longest side. It's the angle opposite of that. Must be my next largest angle. And then finally my shortest angle, or smallest angle, here, angle W. Again, we just go in order of sides, largest to smallest. I guess the angles opposite. Now do be careful when you do these problems, guys. Read the directions, because it's not always going to ask for largest to smallest. It might ask for smallest to largest. It might only ask for the largest. It might only ask for the smallest, or it might ask for the one in between. So make sure you're reading the instructions for that. Okay, questions on this first chunk of examples? Okay, so then our next one here. Name the longest and the shortest side of the following individual triangles. So notice here they're not asking for an ordering, they just want the longest one and the shortest one. So go ahead and give each one a try. I'll give you a few seconds and then we'll go over it. Okay, our first one. First of all, let's find all the measures of our angles. How can I find the measure of angle D? Good. As Amina said, we already know that E is a 90-degree angle because it's indicated it's a right angle. So if I add together 90 and 43, then I get 133 degrees. And there's 180 degrees total in the triangle. So subtract that from 180. We get our remaining angle is 47 degrees. So angle D is 47 degrees. Okay, so which side is my longest side then? Good, side FD. That is opposite of my 90 degrees, my 90 degree angle, which is the largest angle. Notice we're talking about the side, the figure, so make sure you have the segment over top. We're not talking about the measures. Alright, and then which one's my shortest side? Good, ED. My smallest angle is F. The side opposite of that is ED. You'll notice, too, that the letters that are used, the angle opposite of the side is going to be whatever remaining letter there is. And same with the side opposite the angle. Here we had angle F, so the side opposite is ED. You'll notice you then have all three letters F, ED. Angle E, the side opposite of that is going to be your other two letters F and B. Okay, and then how about over here, GIH? How do I find the angle I? Good, same idea as before, 121 plus 32 is 153, and 180 minus 153, 27 degrees. Alright, so then which is my longest side from here? And what's my shortest side? GH. Questions on this so far? Alright. So now let's take a look at the triangle inequality theorem. Now this is something you probably already know from previous classes. No, because GI is the same thing as IG. You're perfectly fine. When we were talking about congruent triangles, if you were saying this triangle is congruent to another triangle, you gotta make sure the corresponding pieces were the same. So we're just talking about that segment there. GI is the same thing as IG. Good question. Alright, so our triangle inequality theorem. A theorem that has a title again. Alright, Eric, what does the triangle inequality theorem mean for me? Good! Who wants to translate that?
Any two sides of the triangle have to be greater than the sum of them.
Good. The two sides added together must be bigger than that last side. So this is something you may remember from, do you guys remember this from previous classes? Yes? No? Maybe so?
What about the doesn't it that or is that
This, it's only right triangles, you're right.
Oh.
The sum of the squares, when they're equal to the square of the third side, that is right. That's the back side. Isn't that exciting? Okay, so our triangle inequality theorem, the sum of the lengths of any two sides, we should say up here. Is that what you were saying earlier?
Yeah.
Oh,
Of any two sides of a triangle is greater than the length of the third side. Okay, so I'm going to just go and draw an example here. Let's say, let's call this side little x, side little y, and side little z. If you add up any two sides, it must be greater than the third side. So if I add x and y together, that has to be larger than z. If I add x and z together, that has to be greater than y. If I add y and z together, that has to be greater than x. So any two sides added together has to be greater than that third side in order for it to be a triangle. If that's not the case, then it's not a triangle. Of something that does not look like a triangle?
It looks like a triangle that has three sides and it's not a triangle.
Yep. So let's say I have this. Let's say, just for example, this is length 2 and this is length, I don't know, 7. Let's say my third side was only length 1. If I swing this side around here, if I take this side and swing it around, sure I can make it connect, but then it's no longer length 7, right? So that would be an example there. I can take this length here, and I can move that around. Hold on, wait. I can move that to meet my other side, but then that triangle that it creates is not length 7 there. So it has to, those two sides have to add up to be greater than this in order to create that triangle. Yes?
There aren't any like closed shapes that aren't triangles, right? Like the three sides.
A closed three-sided shape that is convex, not concave, is a triangle. You'll learn about convex and
Are there
concave.
any like closed three-sided shapes that aren't triangles?
No. No. Okay, so let's take a look at some actual examples using this. One thing we use this for is to decide if these given three sides can create a triangle. So is it possible for a triangle to have sides with the lengths indicated? So to check this out, really the quickest thing to do is just take your smallest two sides and add them together, see if they're greater than that last side. Because in our three lengths here, if the smallest two ones add up and aren't larger than the third one, that means it's not going to be a triangle. If they do, then that larger side added with any of the smaller sides is going to be greater than that smaller side. So take your two smallest sides, add them together, and see if it's bigger than your third side. So my two small sides here, 8 and 9. And what does 8 plus 9 equal? And is 17 greater than 10? Yes. So these added together are greater than my third side. So yes, it's a triangle. Okay, letter B. What are my two smallest sides? 11 and 5. And what does 5 plus 11 equal? And is that greater than 16? No, it has to be greater than. It cannot be equal to. If it's equal to, it ends up just being a straight line on its side. Alright, so no, this is not a possible combination for size of triangle. I don't think so. I think you have to add like area with it. Okay, questions on this? Alright, now finally making us do some actual thinking with these types of problems is they give us two lengths of the side, so they give us two sides, and they ask what is the possible range of values for that third side. Okay, so again, remember for the triangle inequality theorem, any two of the sides added together has to be larger than the third side. So we don't know what that third side is, so let's call it x. Okay, some unknown value. So if I add together any of my two sides, that has to be greater than the third side. So let's take my unknown value and add 3 to it. That must be greater than 5. Alright, so if I take x and add measure 3, it has to be greater than 5 in order for it to be a triangle. Also, if I do x plus the 5 length, that must be greater than 3. Right? Again, satisfying the triangle inequality, any two sides added together must be larger than the third side for it to be a triangle. And then we need our last combination to be 3 plus 5 has to be greater than x. This takes care of the 3 possible combinations. We have our first two sides added together, 3 plus 5. We have 3 plus x, and we have 5 plus x. So these are the conditions it must satisfy in order for it to be a triangle. So let's see where this takes us. Well, let's solve for x. Subtract 3. I get x is greater than 2. Solve for x over here. Subtract 5, I get x is greater than negative 2. Then let's solve over here. I get x must be less than 8. I'm going to turn that around if you like to have x on the left. Okay? So these are the conditions placed upon x. Let's see if we can compile it together in one statement. So if x is greater than 2, doesn't that also satisfy this middle condition that it must be greater than negative 2? Right? So this takes care of that, right? So we don't really need that because it's already been taken care of. Alright, so we know x has to be greater than 2, but it must also be less than 8. So our possible range would be anything between 2 and 8.
But is it?
It does not include those because it has to be greater than, not equal to. It's not allowed to use. So this is my possible range of values. So I could have 2.1. I could have 7.99999987623. I could have 5. I could have 4. Anything between 2 and 8 will satisfy the conditions for this to be a triangle. Okay, questions on that? Okay, go ahead and give letter B a try.
That's X.
Alright, listen up to the explanation of letter B. Check to make sure you got it right.
Well, it is something it's not.
Alright, listen to Liam's explanation of how he went about doing this one.
Alright, Liam. Yeah, you might want to get the class to quiet down. Quiet down, please. I'll give them detention then. So, x is greater than 2.
Well, how'd you get to that point?
Because I'm getting there, Jack. Because x plus 13 has to be greater than 15, and the difference between 15 and 13 is 2. So
You write that down?
I don't know. I think you have a brain. And then it's 28. X is less
They
than
go over
28
handwriting skills.
because
78?
that's 28.
And Liam, how did you know it has to be 28?
Because 15 plus 13 is 28, so it has to be less than that. And that's right. That's true. I think.
Okay, so as you see, this middle stuff, when it gives you that negative value, it's just basically the same idea as this, where your unknown value added to one of the two sides together. So he went ahead and said, okay, well, of my two sides, the difference there is 2. So I have to have at least 2 added to, I have to have over 2 added to 13 in order to be larger than 15. And he knew that 15 plus anything over 2 is definitely going to be larger than 13, since 15 is larger than 13. So that satisfied this bottom requirement here, x must be larger than 2. Then he said, okay, well, the other requirement must be that these two sides added together have to be greater than my unknown side. And so those two added together is 28, and that has to be greater than x. So doing our equations over here, what you would have had written here is x plus 15 must be greater than 13. X plus 13 must be greater than 15. And 15 plus 13 must be greater than x. That allows you to get these results here, that x must be greater than -2, x must be greater than 2, and 28.
X must be less.
X must be less than 28, so 28 is greater than x, x is less than 28. So we combine it together to get 2 is less than x, which is less than 28. Okay.
All of them imply
So for set notation is x such that 2 is less than x, which is less than 28, for x belonging to the real number.
Yes.
Yeah, this is set notation, you're right. If it requires the set builder notation, then that would be what you put. Make sure then, okay, that you don't forget your x belonging to the reals. They probably didn't have you do that part. Mm-hmm.
Why can't it be
Okay. Show me thumbs up, thumbs middle, thumbs down. How you feel with this first page, the front side? Great.
square plus, it's like something square plus.
It looks like you're gonna hang yourself.
All right, Kate.
No, look at Kate. It looks like he's gonna hang himself.
Thank you. Okay, Pythagorean theorem. Raise your hand if you've heard these words before. Everyone should raise their hand because I've said it already this year.
Miss
Pythagoras was in
Okay, Pythagorean theorem. This holds true only for which type of triangles?
Right.
Right triangles. It is imperative that you remember that. This is only for right triangles. Alright, so Pythagorean theorem, our longest side is the hypotenuse. I think that one was me. Oh golly, it's a red light.
Oh, golly.
And the Pythagorean theorem says that if you take the hypotenuse and you square that, and which side is your hypotenuse? Good, the side opposite of the right angle, which in a right triangle is always your longest side. that is equal to the square of the sum of the squares of our other legs. So our legs are going to be the other two sides.
Ooh, the recording saved.
That's right.
So lucky.
So our legs are the other two sides. We square those, add them together. It should equal our hypotenuse square. So for our picture here, triangle ABC. Okay, so you'll often see this is done. The side opposite of angle C, let's call that little c.
Ooh. Shouldn't it be big soon?
And the side opposite of angle B, let's call that little b.
What's that have to be little?
And the side opposite of angle A,
Right.
lowercase a. So that way we don't have to say AB, BC, AC. Okay, do you writing this down? Okay,
These two the same.
so our Pythagorean theorem, this is simply stating that a squared plus b squared, the squares of my sides added together, must equal my hypotenuse squared. If that is true, it's a right triangle. If it's a right triangle, that must be true. Okay, so our first one says find the value of x. What equation am I going to set up here for letter A? 3 squared plus 7 squared equals x. Good. This is my hypotenuse, side x. So 3 squared plus 7 squared is x squared. That gives me 9 plus 49. And what is 9 plus 49? Alright, now a couple of key things here. When I take the square root of both sides and I am solving, what must I have?
Oh, plus or minus.
Plus or minus. But we're talking about a picture here. Measures of the sides. Is it possible to have a negative distance? No, we don't have a negative measure. So our only answer for this is x equals positive square root of 58. Now do double check because sometimes your side isn't just x. They might give you x squared, in which you would take any negative and make it a positive value. Also, anytime you have a radical, make sure you check to see if you can simplify it. Now 58, if we break this down, this only breaks down into 2 and 29. And that, we don't have any perfect squares there, so we can't simplify anything. Make sure, though, you do simplify all of your radicals. It is imperative you do so, and you will most definitely lose points if you don't simplify. It is a huge thing for Algebra 2, so I'm getting you in the habit of it now. Alright, letter B. What's my equation I set up for this one? Good. Notice my x is now on my side. X squared plus 7 squared equals 10 squared.
Can you just square the whole thing?
Great question. Let's take a look at it. Can I just square root like this? And then what are you wanting to do from there?
X plus 7 equals 10.
You want to do this here? Alright. So you're saying
You just pushed it.
that
Yes.
the square root of 4 plus 9 is simply the square root of 4 plus the square root of 9? Let's check that out. What is 4 plus 9?
That's exactly square root of 13.
And what is the square root of 4? And what's the square root of 9? And what is 2 plus 3? And does the square root of 13 equal 5? No! This is not a linear function. But thus, you cannot break up that operation of addition and subtraction. Just like if I had x plus 4 squared, that is not x squared plus 4 squared. It's not a linear function. Do not do that. Do not do this. You make my blood boil when you do that.
It's on the
So do not do those things. So let's try this again.
We found a pet peeve in this part.
Oh, that is most certainly a pet peeve.
What are the math pet peeves we have?
Okay, so let's do this the proper way.
I think she's...
When we subtract 49 over, what do we get? squared of both sides. Can we break down 51?
Wait,
no.
I can't see.
It has no square.
We can break it down, but none of them are perfect squares, so it doesn't do us any good. Alright, so we have x equals plus or minus the square root of 51. But can we use the negative here?
No.
No, because that gives me a negative for that side, so it's just positive 50. Square root of 50. We end up only with one solution. Alright, questions on that? Okay. We are going to come back to these two. These are my favorite. Alright, so we're going to skip those for now and come back to them. I want to go down to the bottom two theorems.
Why don't we get
If the square of the longest side of a triangle is greater than the sum of the squares of the other two sides, then the triangle is an obtuse triangle. Okay? So,
Thank you.
let me show you this picture here, see if this helps out some. Let's call this x. Whoops. Let's just do x, y, and z. Little x, little y, little z. My sides here. So if the square of the longest side, so y squared, that's my longest side, is greater than the sum of the squares of the other two sides, so x squared plus z squared. If your longest side squared is larger than the sum of the other two legs squared, then we know it's going to be obtuse. If the sum of the longest side of a triangle is less than the sum of the squares of the other two sides, then it's acute. So if it's greater than, it's obtuse. Let's take a look at over here. So let's go with same orientation. Again, y is my longest side here. Go ahead and give you your arrows on the screen. Okay, so again, if the square of the longest side is less than the sum of the squares of the other two sides, then it is acute. So if your longest side squared is larger than the sum of the other two sides squared, obtuse. If it's less than acute. What do you think it is if it's equal to? Right, yeah. See, notice how it mimics the Pythagorean theorem? The longest side squared equal to the sum of the other two squares means it's a right triangle. If it's greater than, then it's obtuse. If it's less than, then it's acute. Or sorry, if it's, I did that backwards. If my longest side is greater than, then it's obtuse. And if my longer side is less than, then it's acute. Okay, so let's take a look at a couple examples with this. It says determine whether a triangle can be formed with sides having the given lengths is acute or obtuse. So they gave us our three sides, and we can use that information from those theorems to decide based upon solely the sides given to us, is it acute, obtuse, or right. Okay, so let's take my smallest two sides. So here we have 6 squared and 7 squared. And we decide, is my longest side squared? Is this going to be greater than, less than, or equal to? As well. Okay. Alright, what is 6 squared? And 7 squared? Okay, you with us?
Of course.
And 8 squared is 64. What is 36 plus 49?
64.
Good, 85, which is greater than 64. So my longest side squared is smaller than the sum of the other two squares. So what does that mean for us? It's acute. Good. if your longest side is less than. Your longest side is less than, so it's a cube. Okay, then letter B. Notice the sides aren't always given to you in order. Alright, so what are my two smallest sides?
7 and 14.
Good. And again, we have to decide, how does this relate to my...
Why would you choose these numbers?
How does it relate to 15 squared? Alright, 7 squared is?
49.
And my favorite square is?
196.
And what is 15 squared?
225.
And what is 49 plus 196?
240.
Is it 245? And is 245 greater than, less than, or equal to? So what type is this one? Another cube. Again, my longest side squared is less than the sum of the other two, thus it's a cube. Alright, questions on that? Okay, let's go back up to C and D. These are some very important ones. Okay, so we're back to solving for x. What type of triangles are these? Right triangles. So what theorem can I use? Pythagorean
Actually,
theorem.
probably more.
So first, let's set up each of these equations. For letter C, what is my equation going to be?
X squared plus.
Okay, I heard x squared
Plus 2x squared.
plus 2x squared?
No,
Good. Equals, and this part is important. It's the quantity 2x squared. A lot of people forget to square that 2 with it. It's the whole side is squared. And also be careful to recognize where your hypotenuse is. Don't fall into the trap that this looks like at first glance it might be a lake. 2x is my hypotenuse. Alright, what's 12 squared? And what's 2x squared? Good. Don't say 2x squared, that will also get my blood boiling. Okay, now we see we only have x squareds. So
you have to factor it, right?
you could factor it, but there's an even easier method.
You can minus the x squared.
Yeah, let's just subtract my x squared.
That's hard.
Oh, you can do that real quick off to this side.
Of course.
Boom, done. Okay, now we have 48 equals x squared. Then take the square root of both sides. Oh, do you think perhaps we can simplify that square?
Not.
48 breaks down into 16 and 3. Or you could do 6 and 8 and break down each of those into 2 and 3 and 4 and 2. So then I get 4 square root of 3 equals x, and we should have a plus or minus there. But can I use that negative this time around? Still can't use it yet. So my side is only positive 4 square root of 3. It is an actual number. Why are you hating on the square roots? What's with you and radicals, huh? They don't get much of a place here in mathematics. They need more. No. Alright. Then we'll just set up our equation for D. What's my equation for D?
It's the same answer. It's the same answer.
It is not the same answer. Oh, it's so not the same answer.
Oh my god.
What do I have to do with this guy here?
Are you serious? Are we
Boil it. Then you need to factor it.
Boil?
Yeah. Your homework is on the bottom of the page. It's out of the textbook. Complete that for next class.
what if I
Abby's like, we're not trying to get home.
Because
I
I didn't.
Hey, I like that our bigger.
Wait,
He's been good.
when you're
Great. Because if you keep that up instead of having the music, see how easy it is when you're actually studying. Imagine that. God, if you can't get it, then